Hello, Dr. Devac, and we're talking about lab safety. And in this video, we're going to talk about understanding the risks of the chemical reagents that you're working with. How do we find out about those reagents? And there are going to be two ways. One is going to be the labels, and the other is by using SDSs, safety data sheets. Now, you've been looking at chemical labels all your life. Here's, or at least since you can read, here's a bottle of Mountain Dew, and the chemical label are the nutrition facts that are on the back that you've probably read at some point. And in this bottle of Mountain Dew, there's carbonated water, and orange juice, citric acid, things like that. But there are also a bunch of chemicals. Though of course, those are chemicals too, but the things that have formal chemical names: sodium citrate, sodium benzoate, calcium disodium EDTA, etc. And so those are important labels in your real life when you read about foodstuffs, but labels in the chemical lab are of even greater importance to you now that you're becoming a chemist. And so there are two types of labels. They're the older labels from the NFPA, they are a diamond, and then there are the new GHS labels. They have these 9 different pictograms that you see in the center. And even if it seems obvious in the chemical lab, nothing's ever obvious. You see a bottle and you think it may be harmless, but you really need to look at the label and see what it's all about. And so let's talk about you making labels to begin with. You may want to bring a Sharpie to lab. There's probably one available in lab, but you may want to bring your own. And this is for writing on labels that you'll be making for the solutions that you'll be making. And so whenever you're making a label for a chemical lab, there are 3 things as a minimum you ought to put on there: the chemical name, the date, and your initials. And so here's a bottle of 5 millimolar 110 phenanthrene that was made by ATB on October 20th, 2020. And so that's the simplest label that you can have. 110 phenanthrene is a reagent that we might use later in this semester to analyze iron by UV vis spectroscopy. Here's a label that shows the NFPA diamond that we'll talk a little bit more about, but they have 3 important things. What you have: 0.1 molar sodium hydroxide, your initials JCF, and the date 9/10/20. So this diamond, this NFPA diamond, National Fire Protection Agency, is an older type of label. It goes from 0 to 4, with 4 being the most hazardous material. The blue refers to the health hazard. The red diamond within the diamond is fire hazard. The yellow diamond with the diamond talks about the reactivity or the instability. And then the white diamond tells about anything special about the reagents, such as if it were reactive with water in a hazardous manner. What we now use is the globally harmonized system. And under GHS regulations, each chemical product must contain 3 things: the product identifier, or I can't count 1, 2, 3, 4, 5 things. Product identifier, the signal word, the pictogram, a hazard statement, and supplier information. So those 5 things are on GHS pictograms. And so it's important to note that the numbering system is different for the 2. The NFPA has 4 as the most hazardous, whereas the GHS hazardous communication, 1 is the most hazardous. And so make sure that you got the differentiation of those in your mind. And since many chemicals have a long shelf life, you may find containers with the NFPA diamonds for many years ahead in the chemistry labs. And in fact, on some labels that you might be making. The GHS hazardous communication labeling system began in 2014. And it was developed, it's an internationally agreed upon labeling system developed by the United Nations. Is meant to replace the assortment of labeling systems for hazardous materials around the world. And so each pictogram consists of a white background that's framed with a red border and an icon in the middle that's very distinctive. And so maybe you can take a guess at what some of these are. And then we'll look at the next slide and see what they mean. And so the upper left, we'll do these horizontally going across, shows you a bomb going off or something like that, so that's explosive. Then the flame tells you it's flammable. Then the flame with an O tells you that it's an oxidizing agent. And then the middle row, the gas cylinder silhouette tells you it's compressed gas. The exclamation mark tells you that it's a harmful irritant. And then the bare limb tree and the fish that's floating tells you it's an environmental hazard. The silhouette of a human with a starburst on their chest denotes a health hazard. And the corrosive symbol, pouring something on a hand and an object showing some corrosion taking place. And then the old skull and crossbones tells you that it's toxic. And so before we go on to that, let's look at this label. And here's some nitric acid. And you'll actually see that we got a barcode from the chemistry department when we received it. And it's from Acros Chemicals, and it tells you it's nitric acid, ACS reagent. It's 68 to 70% solution in water, which means it's concentrated. And then there are a couple pictograms, and there's a flame with the O that says that it's an oxidant. It's an oxidizing agent, and it's got the symbol for the corrosive on it. And so that's the GHS label. And here's a label. Here's a bottle of formic acid. And once again, our stockroom label. And then the pictograms that show it's flammable and corrosive and toxic. And it came from Fisher Scientific. And then it has some other information on there about some protective gear and the poison control center and things like that that you might need in a hurry. Same type of info would have been on the bottle of nitric acid. Okay. So SDSs, formerly called MSDSs, and they provides information about procedures for handling or working with substances in a safe manner. Includes physical data such as melting point, boiling point, flash point. It can also talk about health data that you might need, the toxicity, the health effects, long and short-term, chronic, acute, and first aid procedures that you might need to go through. It'll talk about the reactivity, how to best store the material, and how to go about disposing it. If you need any special protective equipment, it'll be found in the SDS, and any spill handling procedures that might be out of the ordinary, it'll talk about those. And you can find SDS sheets with a Google search. Our inventory system, when you call up the material, the substance, it'll link you to the SDS. And then in the lab, you'll find a notebook with hard copies of the SDSs. And so that's a little bit about labeling and about SDSs. And they're important things for you to know about as a chemist and put them to use as you go into the lab. If you're doing your pre-lab lecture, pre-lab study beforehand, and you see a chemical that's labeled as hazardous, go ahead and read about it. Probably a good idea to read about all the chemicals that you're going to be using in lab before you ever get there, so you'll know how to safely use them. Be safe in lab. Thanks for watching.